DC drives, both the converter and then chopper drives. So now today we'll see these AC drives. AC drives.
Hello, sir. Good morning, sir.
La.
Sir, Sonom is sir. Sir, any Zoom ID share bedalo. Ngada sanjitalo share beso.
Sorry, man. Cheat ya. Cheat the Sanjita Daru and benches Jisuno. Sanjita also you can send to her.
So last cast any join bemaso sir. Share mashi sir.
To okay, I'll keep here. And share with them. So this the share that really limit to be really link integration as is problem. So from next time I will share.
Okay, sir. Thank you, sir.
And Sanjita also, no? Sorry, Andy.
Sir. WeChat na group chizo achimitu sir. And link directly
WhatsApp, not in WeChat. WhatsApp you can make it.
Ana link direct ana send bewachin sir. Astamni me
sir. WhatsApp na zote.
Yes, sir.
You can make it WhatsApp na chan. Maybe 2-3 classes. By end of this month, we should be able to complete. So Sanjitana, if anyone can share the link.
Sir, I did, sir.
Okay, same way did almost. So sorry for that.
Okay, sir.
Okay, so now we'll go with this solid state speed control of AC drives or electronics control of AC motors. So like speed control of AC motors, especially this induction motor, using the conventional method we have already discussed in the machine, AC machines. So then if you can just go through this. These inverters or this AC drives, the speed control of AC drives actually involves the use of inverters and voltage regulators. You see, so voltage regulators are there. Then another, so in AC motor drives, usually we use these three-phase inverters. Okay, so three-phase inverters are usually used. So it can be either 180-degree conduction mode or 120-degree conduction mode. Okay, and these three-phase inverters can use control turn on as well as turn off devices such as, so the switches can be, you can use BJTs, MOSFET, IGBTs, MCTs, SITs or GTOs or force commutative thyristor as per their application where they are going to use. Okay, so these are the case. So now another advantage of this AC motor used in the drives are they are normally light in weight compared to that of equivalent DC motor. So that is AC. And another reason why we are preferring AC over DC is because of the fact that the most widely available and supply is AC. So that is why we are using this AC DDR, the main one. Then another one is AC drives containing power converters. Inverters and AC voltage are capable of controlling voltage, not only current. So it will not only, so one parameter, remember, so it will control so many parameters. So it will be able to control voltage, it will be able to control current, it will be able to control frequency. Okay, so that, so as per that requirement. So that is how this, because of this, again AC we are using. Another like thing in this AC motor which are used in this are like they are robust. So this which we require, which we have seen, you can see this is like robust construction. See this induction motor and all this. They require less maintenance and then can be designed for higher speed also, torque and then power rating. So design can be done for that different ratings. And another advantage or the desirable characteristics of AC drive is that they have flexible characteristics, means can the speed can be controlled except for that synchronous motor, otherwise it is, and then can operate in all 4 coordinates. Okay, so you will be able to operate in all 4 coordinates. Okay. Then types of AC drives are, there are many types of AC drives, but majority can be grouped under static frequency changer. You have static frequency changer, then static voltage controller, then rectifier or inverter system in line commutation, then rectifier and inverter system with force commutation, you have, or self commutation, and then PWM system. So these are the 5 different types of AC drives which we can. So depending upon the types of this, so static frequency changer, voltage controller, rectifier, inverter system with line commutation, then self commutation, and then PWM system. So pulse width modulation. So in short, we can have this PWM. Okay, so PWM system. So these are some of the cases. Then types of AC drives continue. So you can have, first type you have is static frequency changes. So in this case, what it does is it converts incoming line frequency directly into the desired load frequency. So the example of such converter is cyclo converter, and they are used to drive both synchronous motor as well as squirrel cage induction motor, SCIM. Okay, so that is, so this is the case. Variable speed, so 3-phase source, you are giving cyclo converter, then motor. So it is there. So through this, so now you have this control and firing unit is there. So control YU, so appropriate you. So first you will give is what you are going to use. You will give the real values of voltage, current, speed, etc. Then it will control it, then give it to the fire, and then after that controlling, then it will make it appropriate for that particular motor, and then it will give it to the appropriate frequency, and then it will be given. So this is how you will have that. Okay, limit the Nistigara, everything here it will be there. So this is what you will have. Then another type is static voltage controller. So this type of controller, what it will do is it will enable the speed and torque control by varying the AC voltage. So it will enable speed and torque control. So you can, if you want to control the speed and torque of an AC motor, then this method is used. They are used with the squirrel cage induction motor. Also, the static voltage controller are also used to soft start the induction motor. Means you can start starting method of induction motor. So this is another one. Again, desired speed you will give, then so this is what. Then this firing angle is given, then to the switches. Okay. Then third type is rectifier inverter system with line commutation. So in this case, what it does is it will rectify the incoming line frequency to DC, and then DC is reconverted to AC by an inverter. So this is the inverter then in turn is line commutated. So that is why it is called as line commutation. Line commutated means as soon as it crosses 0, it will be turned off. So, and this is shown in this, and this type of system is mainly used to control the synchronous motor. So mainly for synchronous motor, MS or SM. Okay, so that is. Then such type of system are also used to control the speed of wound rotor induction motor, as shown in figure. So this. Okay, so this is the case. Wound rotor, that is. Then another type you have is rectifier inverter systems with self commutation. Rectifier the line frequency DC, same thing, but here the only difference is self commutation. And this inverter is self commutated, generally generating its own frequency. That is, and they are used in squirrel cage induction motor. So this is. So here 24, same thing. So that is self commutation. Okay. Then another type, last one is PWM system. So this is actually like new development. as compared to the other, and then it is means recent development used in this. So here you are actually controlling the pulse width of that AC type key, frequency and all this thing you are controlling. So what it is doing is here actually the variable speed induction motor drives ranging from 0 to the rated speed. Okay, so from 0 till rated speed. So now why they are widely used in this industrial application, or they are known to the market, this PWM system type of system, speed control for AC types, are widely known in the market because of this high speed switching devices such as IGBT. Okay, so because of this it is known in the market. So this is why well known in the market because of using this IGBTs. Okay, high speed. So this is okay. Then now just speed control of induction motor. So all this one is all electronics part. Okay, so you will have is using this power electronics devices. So electronics, conventional we have already seen. So electronics. Okay, so conventional we have already seen. Okay, so for induction motor we know that this is there. Imo andi. Just refresh it. You can just see. Or you have is S is equal to what you have, N S minus N by Ns. So this is what you have, slip speed. So this is slip speed. So from there you can get this motor speed. Okay, so motor speed you will get from this. So from this equation 4.1, you can see that speed of induction motor can be changed either by changing this synchronous speed or by changing this slip S. Okay, so changing slip S. So two methods. So therefore the induction motor can be controlled basically by two methods. We have is from stator side and then from rotor side. So from stator side what we have, you can change by changing the supply frequency to control the NS, because how it is NS, how it is related, NS is equal to 120 F by P. Since P and 120 are fixed, so NS is directly proportional to. So this is supply frequency control. That is there one. Then second one, any other? What do you have? Any other option here? Second method. What is the second method? Third method. Any other methods? Hello? So second method, supply voltage control. Third method, controlling of number of stator poles. Then fourth one is adding rheostat in the stator circuit. Soft starting zone limit, that is what you can. Then another is from rotor side. So you can adding external resistance in the rotor circuit and then cascade control. Okay, so then injecting slip frequency voltage into the rotor circuit. These are some of the means, be it conventional or electronics. So you can use this one. Okay, so conventional method as well as electronics. So now you can use this various method of speed control through semiconductor devices are. You can have is stator voltage control, frequency control, voltage and frequency control, current control, static, and then slip ring. Then serial number 1 to 4 are actually applicable for both SCIM as well as WRIM or slip ring induction motor, while 5 and 6 are used only for slip ring induction motor, okay, or SRIM or WRIM. Okay, so slip ring induction motor. So that is what we can. So first, voltage frequency control or supply frequency control, that one we have already done. So just the synchronous speed, which you can see that. So that is also there. Now air gap flux is given by there. So from this you can see that supply. So you can just go through it. Same thing, whatever, I have not changed anything. So whatever we have discussed in this AC machine, same way. And the only thing is now this here. So here you are using this inverter. Okay, so this is. So that is why you are input AC, then convert, it will convert into DC, then it will give it to AC again. This AC will then change to variable voltage, variable frequency, and then AC supply. Then it is given. Okay, so this is what it will. So this is for the variable energy. Then sleep power recovery schemes. In this method, we will directly go to other method. Okay, so in this method, what you are doing is voltage is injected into the rotor circuit. So voltage is injected into the rotor circuit, and what you are doing is the frequency of rotor circuit is a sleep frequency, and hence the voltage to be injected must be at sleep frequency. That you have to keep in mind. Okay, so voltage is so in sleep power recovery. Then other point you can have is it is possible that the injected voltage may oppose the rotor induced EMF or may assist the rotor induced EMF depending upon the direction of the induction. So if it is in the phase opposition, what will happen is the effective rotor resistance increases. If it is in the phase of the rotor induced EMF, effective rotor resistance decreases. So this is just for this method is used for WRIM. Okay, wound rotor induction motor, or you have this SRIM, rim and SRIM. So you have sleep ring induction motor. So therefore, how you can control the see, therefore through about 4 points, now you can conclude it is that the magnitude of the injected EMF, rotor resistance, and effective speed control effectively. So by controlling the magnitude of this one, the speed can be controlled effectively. So this is what we can. So practically for this sleep power recovery scheme, two methods are there. So we have one is Kramer system and then Schreiber's system. So two methods are there. So this is your Kramer system. Induction motor, then sleep ring on the base. So in this case, what you have, in this case, it contains induction motor. So this one main motor to control the speed. Then there are two additional one, that is DC motor. So this and the rotary converter. So for coupling purpose, that is the similar to that of Anikachilo Damachi. What you have done in this other case. Leonard system. So here sleep ring of the main motor is connected. So here sleep ring of main motor is connected to the AC side of the rotary converter here. So main motor is sleep ring to this rotary. And then the DC side of the rotary converter feeds a DC shunt motor here, which is directly connected to the shaft, mainly to shaft. Then you can, the separate DC supply is required to excite the field motor, and then why? Because you are separately excited bending, so it is there. Then the variable resistance, this one is introduced just to vary the field circuiting. That is where you will have field circuit. Then the speed of set is controlled by varying the field of the DC motor with rheostat R. So with this you can control the speed. Okay, so this is your conventional one. When the field resistance is changed, the back EMF motor changes, thus the DC voltage at the commutator also changes. This changes the DC voltage on the DC side of the rotor converter. So, and side voltage, thus the voltage on AC side also changes. So because of this, it changes, and hence the speed changes, which produce the required speed control. So by injecting the voltage to the sleep ring, you are changing the speed. Okay, so that is what you do. So here now very large motor about 4,000 means 4 megawatts, such as ST rolling means use this such any system. So uses such system. Okay, so that is what you can this use. And the main advantage of this method is that it produces smooth speed control. Okay? And also wide range of speed control is possible. Okay, so these are some of the advantages of the Kramer system. And then another advantage of this is that the design of this rotary converter, this converter is independent of the speed control requirement of speed control. Then we can now added advantage of such this one is, like if the overconverter is if the rotary converter is overexcited means then it will draw a leading current, and thus power factor improvement is also possible along with the speed control. So on top of controlling the speed, this system can be used to improve the power factor of the system if the rotary converter is overexcited. If it is underexcited, then power factor again it will not be able to improve the power factor. Okay, so the Shriba system Dandi, so we'll discuss in the next class given. Then go into one. Okay. So class test, we will have class test on May 29.